Hello, everybody. Welcome to the third week, I guess, of our instruction. This is the 30th of March. First of all, I wanted to show you that I did fill out my census, and I wanted to just show you some of the interesting questions on there. First of all, for all of the people in my household, they asked what sex we were, and male and female. Male and female were the only two options. So for folks that really don't want to specify what they are, I'm not really sure. There wasn't really a choice at all. I guess there was a help button. I didn't press it, but just wanted to point that out because I guess with the gender fluidity in our country and in the world nowadays, that wasn't an option. Male, female, that's all you had. The second thing I wanted to point out, which I thought was kind of interesting, folks overseas have always said to me, "Oh, Americans are so into well, what's their nationality? Oh, we're American. No, no. What are you really? Oh, well, I'm Ukrainian, and I'm like, German, I'm Italian, I'm Scottish." There was a question on the census for every one of my children and my husband and me that asked one if we were Hispanic, which we're not, and then two, it asked what our origins were. And I thought that was kind of odd. My father's family's been here since the Mayflower came over, so it's kind of a little bit weird to be asking what my origins were. So I just wrote down European, but I just wanted to show you some interesting things here. For instance, Black and African American. You check it off. You're supposed to say, "Are you from Jamaica? Are you from Africa?" I mean, I don't even know. Some people probably don't know where they're from, based on this. So I thought it was kind of interesting. Um, because not everyone knows these things. So in any case, and then I guess the Asian, it certainly makes sense because if you check off Asian, that really goes all the way from like Afghanistan all the way over to Korea. So that kind of makes sense. But again, the same idea that it's like, well, why do they want to have such specificity? In any case, just wanted to show that with you and share it with you. So today we are going to be first doing a do now on what we did on Friday. Please make sure you're doing all the lessons. We are planning to have a test on Thursday. I don't know if everyone saw that. It'll be on chapters 20 to 22. I figure we'll do some wrap up tomorrow, review on Wednesday, test on Thursday. So my do now is shown here. Take a moment to look at it. I have the three questions written down, and I will then start my work. Okay, so standard error. Remember what we do is we're going to add up we're going to add up the variances, but what we're going to do is we're going to take each of them individually, and we're going to divide them by their total uh, in each grouping, and then we're going to do the square root. So the standard error in this case, I figured out that the for the herbicides, 57% of the dogs got a malignant lymphoma, and in the non-herbicide one, only 15% got it. So that's how I did the standard error. Any questions? Let me know. Okay, so second question, create a 95% confidence interval for this difference. We are obviously comparing herbicide cancer rates between dogs, so we are going to be doing hopefully a 2 proportion Z interval, but we have to get through all the steps in order to get to that. So I quickly made the assumptions and conditions. Hopefully you've thought about what they would be as well. The one thing that's clear is that it does not state this is random. So we can say it's representative. They're not saying it's random anywhere that I could see. So we just have to just be leery of that. But certainly it's representative. So it's a representative sample, which can be used as random. Each household is independent of each other. The groups are independent of each other because obviously you can have herbicides or not herbicides, not both. And the success failure condition was met as well. Let me show you that. Hide. So here's the herbicide, no herbicide. I wanted to kind of show it because I feel like I'm making all these lists and we're not writing down everything. You have to write this down. Mrs. J only says create a 95% confidence interval. Do the whole panic. You have to. please. And in fact, the last question stated appropriate conclusion. That's the C in panic. I shouldn't even know how to say that. I could say to something like, what is the interval of the difference? And you should go through all these things. All the conditions are met. I'm going to use a 2 proportion Z interval. So this one I'm going to do with you. So let's go to our calculator. We're going to go to the 2 proportion Z interval. Go ahead and do that. Then we're going to go to putting in our numbers. So there were 473 that were malignant out of 827 dogs. There were 19 that were malignant out of 130 dogs. I did the bigger one first because, we are trying to compare whether the difference of having the herbicides versus not, and I can see that my percentages, 57% is much higher than 15%. So I'm going to do that first. And then my calculation is 95% is my sea level. So then I'm going to calculate, and here's my, let me do that for you, my portion Z test. That's really all I have to write down. So that's going to go down here, below here. So show up. There it is. So state appropriate conclusion. We are 95% confident that the true difference in cancer rates with herbicides is 35% to 49.5% higher than without herbicides. Okay. So you're going to have 35% to 45% higher incident of cancer rates, lymphoma, in the herbicide yards versus the non-herbicide yards. Okay, so let's move on to today's lesson. Starts getting a little tiny bit tricky, not so bad. So this topic, they're talking about pooling. So when we are doing differences, when we're trying to compare differences in probabilities and proportions, what we're trying to see is the hypothesis test we're going to be doing, the null hypothesis is going to be that there is no difference. So just like when we're doing a 1 proportion Z test, we're saying that the null is the standard. In this case, we're trying to prove that there is no difference. And if there is a difference, we will see the probability, the p-value being very small. So our null hypothesis is going to be the null hypothesis colon p1 minus p2 is equal to 0. Then when we're doing the alternative, we would then either have not equal to, greater than, or less than, depending on what we're looking at. For instance, in the case of the herbicides with the lymphoma we just did, I probably would want to do a p1 minus p2 is greater than 0 because I want to see that there is a substantial difference. Is there a difference in the cancer rates? So the interesting thing about doing these is the standard deviation is going to be the same for both of them because we're saying that the 2 proportions are the same when we're doing P1 minus P2, right? We're saying they're both the same. Obviously, they're never the exact same numbers, but that's considered pooling. When we pool the counts, we get 1 overall proportion. All right, so let me show you what that looks like. You can pause at any time. So here is what we would do here. So we're going to say that our success, our p hat pooled, would actually be the success plus the other success over the 2 numbers combined. So for example, in the one problem we just did with the cancer in the herbicides, we would do the success for the cancer in the herbicide yards plus the success in the herbicide non-herbicide yards divided by the total number of dogs we had in our sample. And then obviously the failure would be the opposite. And You have to make sure the successes are whole numbers, round them first. And this is the only time you should round in the middle of calculations, though in stats they do it more often than we do in other math courses. Okay, so here is the standard error formula. The only time I really think you'll ever have to worry about this is maybe in a multiple choice type question, because otherwise I'm going to have my calculator do it. I'm not going to do this math. So here's the standard error. Take a moment to look at it. And what you're seeing is the standard error of the pooled data, P1 minus P2, is going to be the square root of the pooled, but remember this pooled number is going to be the successes, and then the pooled, uh, uh, sorry, the failures, and then you add the same number again, but my ends are going to be different. So let me see if I have an example coming up. If I don't, I have one toward the end, which I'm going to do. Okay, we don't. So I will do one at the end. We reject our null hypothesis if we see a large enough difference in the two proportions. How do we see what's large enough? They're saying compare the standard deviations. Unlike previous hypothesis test situations, the null hypothesis doesn't provide a standard deviation, so we always use a standard error. Okay, fine. So what's our two proportion z-test going to look like? So we have, remember we're doing p hat is going to be the success of one plus the success of the other over n1 plus n2. That's going to be our p hat. Also, the other way sometimes I see, sorry, I want to point out this. Sometimes I see it written like we have up there. The null hypothesis is equal to P1 minus P2 equals 0. Or I also see null hypothesis P1 is equal to P2, which obviously is the same thing as the first one. I see them written both ways. So you just pick which one is better for your thought process. Okay. All right. So our Z. If by chance it came up in a multiple choice type question, what's our Z? This is going to be this is what our traditionally would be our mu, right? Or in this case, it would be our X. This is what we have found in our data. This is our data. So the 0 is just indicating that there is no difference. That's why the 0 is there. So you can write it down. You don't have to because it just disappears, but just to know where it comes. So when the conditions are met and the null hypothesis is true, it follows the normal model. We can use that model to obtain the p-value. Okay, so let's do this example. Take a moment to read it, and then we'll go through the problems. It's basically talking about snoring in groups. Okay. All right, so we have 995 respondents. So we have 37% of the adults reported they snored at least a few times a week. Would be expected in all the same age categories. So we're going to split into two age categories. So we have 26% of them, of the 184 under 30 snored. We had 39% of the 811 older group. Is this difference of a 13% real or only due to natural fluctuations in the sample we've chosen? So we're going to work through phantoms. We're going to figure out whether there, in fact, is this difference, this word difference. I see this word difference, and I think, oh my gosh, I'm going to be doing, in this case, a two proportion Z test. So let's work through the steps. I'm going to say some of them so that way we don't have to worry about writing so much, but we are going to have to go through our assumptions and conditions, and we are going to have to, go through all the normal phantoms we normally do. So we're looking at snorers across the US. These are US across all different age categories in men and women. So the null hypothesis they're already showing us is right here. So we're looking to see whether there is a difference. Is this difference of 13% real or due to natural fluctuations chosen? So in this case, I'm actually feeling like I might want to just do not equal to, but certainly I can see that the numbers are greater than So I'm just trying to think about what I want to do here, and I think I'm going to do not equal to. So I'm going to say the alternative hypothesis P1 minus P2 is not equal to 0, because all I was asking is there a difference? If it said is the difference greater, then I would do greater than or less than. But it says is there a difference? Yes, no, moving right along. Okay, so assumptions and conditions. I'm just looking to see if it says anything about random groups. Um, they had different. Oh, it might say on the top. Random sample. The groups are obviously different from each other because they're different age categories. We should probably assume that the individuals are independent of each other. That's less than 10% of all the U.S. People, U.S. adults, and the NPNQ. I can already see that if I have 37% of 995, I'm going to be above 10, and certainly 995 times 63 is also going to be greater than 10. And then the same thing with 26% of 184. I'm sorry, I'm looking at the wrong numbers. I apologize. I don't want to use this one. This is what I'm not going to use. I'm not going to use this one. I'm using these ones. So 26% of the, let me write this one down because I just messed you guys up. So the NP for the under 30, so the NP greater than 10, and of course the NQ greater than 10. So we're going to have the under 30 is going to be 26.26 times 184, which is 40. I'm going to round to 48, and which is greater than 10. Therefore, 184 minus 48, I'm going to have 136, which is greater than 10. And therefore that would be the NQ. And then over 30, I can't believe they're saying 30-year-olds are old. I approach a non-number like that. And then we have over 30, we have 811 times 0.39, and I get 316. 316, which is greater than 10, and therefore 911 minus 811 minus 316 is 495. 495 is greater than 10. All conditions met. Use the two proportion Z test. Okay, so let's go through the two proportion Z test, what we're going to fill in here. So let's go over here. I do not need to show too much. I'm going to show everything that's on the calculator, though. I'm just going to write it all out. So let's go to stat, tests. I'm going to go down to two proportion Z test. Okay, so I'm going to do, let's see what we have here. So I have it written down, which is great. So I don't need to do too much extra work. I had 48 people. And you know what I'm going to do? I'm going to flip-flop them. I'm going to make the, I'm going to make the over 30 first. Okay, so because I don't want to have any negatives, it's going to make it makes it confusing. I get confused. So 316 out of, what was the total? Sorry. Okay, 316 out of 811. And here it's going to be 48 out of 184. If you notice, it's saying, instead of saying P sub 0, it's saying it's P1. P1 is what? It's not equal to P2. That's what I'm going to do. I'm going to do a calculate. And here's all the data I get. What am I going to write down? I'm going to write down the two numbers in the middle. I'm going to write my Z. Always write my Z. I already see it's a 3.2. And I have my P value. I would write it as P value. So let me just write this down here. P value. Will it come in? Sometimes it doesn't like to. Boop. There we go. Okay, so this is my P value. Let me write it down. P value. Okay, that's my P value, 0.001. So what am I going to say? Because the p-value of 0.001 is, let's write right now. I know you're like, wait, shouldn't we ask for alpha level ahead of time? Absolutely, we should, but alpha level of 0.05. Okay. But we can certainly do it now too, because the p-value of 0.001 is less than our alpha level. Point 0.05. We reject the null hypothesis. There is strong evidence that the difference between young snorers and old snorers is not, let's see what it's saying, is real. Old people do snore more than young people, unfortunately. Something you have to look forward to. Okay, so that is a two proportion z-test. I'm going to stop here. I will wrap up everything for chapter 22 tomorrow. And we will then review on Wednesday. I will definitely have office hours tomorrow and on Wednesday, so you can do your test on Thursday. Have a wonderful day. Let me know via email if you have any questions today. We will not have office hours today. Have a wonderful day. Bye now.